at subset sum problem, which is very important problem. So we were given with an array and we were given with a sum. We had to predict if any of this subset of this array is going to sum up to the given sum. Alright, this was clear. Furthermore, we moved down to an approach to solve this question. We said we could do recursion to find out the answer of this code. Alright, so if you want to try out the code, I'll show you that. Wait. This is it. Let me copy it down here and paste it. Okay, see, this was the code, but I said this code is not optimal. All right, see, even if you run it, you will figure out that this code is going to give you time limit XCTLE error because it is taking more time that is than what we expect it to be. So how you are going to solve this problem? See, first of all, we need to know why this is not an optimal solution. Okay, coming back to our same example. Yeah, coming back to our same example, we had this array. Wait, we had array that was 1, 2, sorry, 2 and 3. All right, and then we had sum equals 4. Okay, so we started with an approach that we were moving from here to here. See, n minus 1 of this array would be 3. So uh, what we did was we started with 3. We had two possibilities. Either we included or we excluded, right? So after we included or excluded, we made a recursive call, right? This portion here, see, this portion here, either we are including it or we are excluding it. All right, this is clear. And if it is greater than some, then we are obviously going to exclude it because it is not going to give us that optimal answer. So this was clear, right? So after this we move to 2 because we have visited 3. Then at 2 we will do the same thing on both sides, and then again, see, after this again we are going to have to make a choice to include 2 or exclude 2 in both cases. All right, so this was about including and excluding 3, but in this is about including 2 and this is about excluding it. This is again about including 2 but with excluded 3. All right, and then excluding 2, and see, again after that we have to make same choice for 1 also. Okay, included or excluded, and same included or excluded. So what is happening? See, for greater number of n, we are going to have to visit the same subtree which we have already know. And we know the answer of this subtree, and we are calculating it again and again. We do not want to visit it again and again. So what we can do? So actually, I am going to just copy this code here and just write it on here to make it more clear. And we shall start from here. So what we will do, we'll come here at this point and we will initialize. First of all, we will initialize something. We'll make a matrix. See, what is the given sum? Given sum is 4, right? And given matrix is ARR equal to 1, 2, and 3. All right. So what I will do after this, I'll calculate n equal to length of ARR, that is 3. So I can make a matrix, and this is going to be a global matrix, all right, because I don't want to make this matrix again and again. I am making it for the purpose that I do not have to check these values again and again. After I visit a node, I will put its value down in the matrix, and if that value is available, why would I traverse down to the recursive call? I'll just return it from there. Alright, so I'll make a matrix with n equal to 3. So I'll make this side n plus 1. Okay, so 3, for 3 it will be 4. Got it? And for 4, I'll make this side to be sum equal to 1. Sum plus 1, sorry. Alright, this will be sum plus 1. So sum is 1. So obviously there will be 5 columns. 1, 2, 3, 4, and 5. These are 5 in total. Alright, this will go from 0, 1, 2, 3, and this will go from 0, 1, 2, 3, 4. Okay, and what I'm going to do, I'm going to initialize all of these with -1. Okay, what I did, I initialize every one of these with -1. All right, I initialize everything with -1, and then what I'm going to do, I'll do the same thing. I'll go from this order, like visiting from 3 and like 3, and what value I will get from this subtree. Like this is node for n equal to 3 and sum equal to what? 4. All right, so see, when I will get value for this n equal to 3 and sum equal to 4, so I'll just go down here where n equal to 3 and sum equal to 4, and I will initialize this with that value. Okay, so whenever again I will have to reconsider this node, I'll just take the value from here, and then suppose I get some value for here where n is 2, right? So at this point in the tree, it means that I have excluded 3, so sum I get here is 4. All right, this was including. So at this point again there was 2, but the sum I get would be 4 minus 3, that will be 1. Okay, so what value I get here will be this. So for sum equal to 1, sum equal to 1, but n equal to 2, I will put that value here. Okay, so whenever again in the tree where I have to check that value for sum equal to 1 and n equal to 2, I'll just bring that value from here and put it there. So you understand the point that I do not have to make the recursive call for every node. Whenever I'm getting a value, I will put it from here. Okay, so what I'll do in the code, what I will do in the code, see, I'll just write one simple condition. If the T array, see, that was a global array that we initialized, would be T n plus 1 and then sum plus 1. Understood? And we initialize this with -1. All right, so see, if T of what? N, sorry, this is capital N, so I'll write it in uppercase. N and what? Sum is not equal to, see, we initialize it with -1. So if it is not -1, it means that it has been initialized at some point before. All right, so I will check if it is initialized or not, and if it is not -1, means it was initialized at some point before, I'll just return it from here. Return what? T of n and then sum. Okay, and one another change that I will need to do is, see, this is the return statement, So I'll just cut it, and I'll return it down. Like, this is in Python. You can implement it any programming language of your choice, but I prefer Python. See again, and I will return something else. So I'll tell you what I will do. Don't worry. See, I did this. Okay, I did this, and what I will do first, I'll just initialize this thing to t of n and sum, because I need to initialize those values, right? And after I have initialized that, I'll just return it. Simple. Return it to here. And again, for same thing for here, t of n and sum, and I'll return the same thing, t of n and sum. Understood? So with these four more lines, I just uh, simplified the whole complexity of this problem. I do not have to read those same notes and visit those same notes again. If I'm finding those values in this matrix, I'll just bring it from here, and what I'll say, this is the memoized code for the subset sum problem. And you can try different variation of subset sum problems, but this is going to sum up to the best thing that I could ever tell you, because dynamic programming helps you to this is actually, we solved this, we converted the recursion into dynamic programming, and with that we reduce the complexity to a great extent. So I'll show you. Uh, uh, See, actually for recursion, I was getting like 2 out of 34 cases succeeded, and the it was simple that I got this time limit exceeded error. But when I tried the memoized version of this problem, I was getting the complete solution for that. And if you do need the code for this, I have uploaded everything on my GitHub, so you can check it from here. And if you know memoization, you can just derive the bottom up approach for this problem as well. In bottom up, what we will do, we'll, instead of having this initialized with the uh, negative ones, we will just go on to the base cases, right? So what we will do, actually, I'll tell you about the bottom up approach as well. So see the same problem. We initialize the matrix like this, right? Yeah. Array was 1, 2, and 3. Sum was 4. So n was length of the array, and becomes 4. So we initialize the matrix like n plus 1, and this was sum plus 1, right? So while initializing, I'll do one just simple thing, 1, 2, 3, 4, and 5. All right, and these will be 4. Okay, this is the matrix. While initializing, I'll, and this 1, 2, 3, and 4. See, while initializing, I'll do one thing. See, for this column, the sum is what? 0. Alright. And we have this base condition. If sum equal to 0, we need to return true. So what we will do, we'll just initialize everything in this uh, code to be true. So I'll just initialize everything to be true. And in this column, n is 0. Alright, number of elements in the array is 0. And we have to bring out these things. So we had this code also. Okay, if sum is not equal to 0, sum is not equal to 0, and n equal to 0 means length of array is 0, then we have to return just false. Okay, so I'll do just this. Okay, false, 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 false. And from here, I'll start iterating. Instead of making recursive calls, I'll start iterating for these values. Like this value is going to answer the sub problem where I have to find if there is subset possible for length of array is 1, where length of array is 1 and some of its elements should be 1. Sum of elements of it should be 1. So see, length of array is 1 means we are talking about this array. Okay, the array should be like arr equal to 1, like this. Okay, arr equal to 1 and sum equal to 1. So we can obviously answer this question, right? We can just say true because one subset of this array is going to answer true. Then based on this subset, I'll move to the next problem. This is saying if length of array is 1, is it possible to make an array that is going to answer and having the sum up to 2? No, it is not possible because this is 1. So I'll just put it false. All right, I'll put it false. Based on this condition, I will just make it make my code like this, because this arr minus 1 will then become arr n minus 2. All right, n minus 2, no, sorry, n minus 1. All right, this will become n minus 1, and then this will become sub minus 1. This thing will become sub minus 1. So I'll just have these thing to be initialized with I and j, like normal programmers do. And if you don't understand, we can make another video about that, but this is very simple. If you know the memoized version, then you can easily derive the top down, sorry, bottom up approach for this problem. All right, so that's it for this video. Thank you.